So here's a water heater. It is made by Thermomate. It's an electric water heater. The model is ES10DE. The device itself looks like this. Two water connectors, a temperature controller. It has a water tank which is of 10 liters. The power consumption is of 2000 watts. It should consume around 9 amps of current. The heater itself is around 32 by 32 centimeters. The temperature of the water should be maximum 75 degrees Celsius. The water hoses have a half-inch connector and the entire package is around 8 kilograms. Manufacturer is in China. So let's open the box. Here's the water heater. It has an overpressure valve. This is the mounting element, and this entire plate should be connected, let's say, to the wall using those screws, conical at that end. And here's a hose for overpressure. That should be connected here, I guess. And that's it. This is the water heater itself. 220 volts European plug. Here's a manual also. It's pretty thick. It's in a few European languages. English is the first. Power consumption is A. It's pretty lightweight, almost 7 kilograms. I can easily lift it. The power cord mentions that electrical appliances of 9 amperes should be connected to circuits above 13 amperes. Use copper conductors only, single outlet circuit only, not to consume 2000 watts from this and 2000 from another and a third one maybe. Length of the power cord is around 1.5 meters. These are the two connectors, cold water inlet and hot water outlet. Both of them look identical, the cold and the warm. They are not thinner or thicker. Now this boiler has the hose connectors on the top, and that means that the hot water output is this one on the left, and that's on the left. And in this case the hot water has a short pipe and the cold water has a long pipe. If the two connectors would be on the bottom, then it would be exactly the opposite. In that case the red one should have a long pipe and the blue a short one. Warm water rises up, and since the connectors are on the top, then the warm one has to be the shorter one. That's from the front and that's a cutaway. So that's the top, that's the front, left side, right side and the bottom. The front has this knob which can be rotated. It just made a click sound. So above this point it's heating the water and below it it's not heating it. It has a snowflake sign, so if you don't use the heater you can put it onto that one and it will maintain a slightly higher than 0 degrees Celsius temperature, so the water will not freeze inside. Prior to connecting the power supply, ensure that the water heater tank is full of water and system is purged of air. This is the left side. Some more information here. This is the right side. This is in German. And that is the back side. Top here and bottom here. The power cord enters on this portion. And the support element, which looks like this, should enter here. The foam is inside the insulation. Here you have two rubber elements. I already removed one, and inside there is a screw here. So let's remove the next one and just pull it out. Now using a star or Phillips head screwdriver, remove those screws around a centimeter long. You can temporarily store those screws inside that. Now let's use a flathead screwdriver, insert it here and somehow lift this up. So this portion is inserted to the left. Gently lift it up. That is inside. We have a diagram also. Here is the lamp. The two rubber connectors were here and there. So power enters here on this side. That enters into this gray square here. Let's say this is the phase and that's the neutral. And it exits here into this blue and into that red. So that has to be the empty here on the diagram. The line is interrupted and the neutral is also interrupted by one single thing which is called empty. So that gray is interrupting both the phase and the neutral. After that, the blue, the output, is entering into this white, which should be one side of the heating element. And the red doesn't go straight into the other end of the heating element, but it comes here to this rotatable knob, which should be the thermostat. And after it exits, then it enters into the other side of the heating element. So the heating element is down here, and that light bulb receives a phase from the thermostat and it receives a neutral from that switch. A black line enters there and into the thermostat. So let's remove these nuts. We have 5 of them, and an anode should be inside, which should protect against corrosion. In the manual I read something related to aluminium instead of magnesium. Usually they have a magnesium anode inside which corrodes, and that protects the inner shell of the heater so that the anode corrodes first and then the walls of the heater. A tubular key cannot enter there, so I opened up this white plastic. There's a screw there, so you cannot easily remove it. This is just a cover with clips on the side. I removed that screw and it can be removed. So it is attached from above. You cannot slide it off. It has just one side. Now remove that nut. The next one also requires the removal of that white plastic. Get a thin screwdriver and open up that plastic. Now the rest of the nuts can be removed much easier. And now let's try to remove the interior, which looks like that. The power wire is also blocking the access, so I better remove the screws and loosen the wire. It is pulled up. This has to be rotated and it's out. So that's the inside of this water heater. Here we can see the longer tube. It has some holes on the end. And it goes up. The longer tube is on the right side. The shorter one is there. That one. So in this case, that's the short one and that's the long one on the inside. This is rubber. The screws are below. They are removable. It's kinda rusty. The rubber gasket is holding those screws. And that's the entire inner unit. The black wire enters into this. So this has to be the heat sensing element, the heat sensor. This curved one is the heating element. That's the 2000 watt heater. And this should be the anode, magnesium or aluminium, I'm not sure. It doesn't look like magnesium. Magnesium is slightly darker. So this is probably aluminium. That's the ground. It has a screw. Now using a larger screwdriver or even this, loosen that. That's around 5 millimeters. That's the element which protects the inner portion of the heater, that blue one. That's the anode. This corrodes first and then the inside of the heater. When this disappears due to corrosion, then it's time to replace it. So this is 5.5 millimeters and the length is 8 centimeters. Anode diameter 19 millimeters. Thread it back. Okay, so let's put everything back. This element, which is interrupting the power, is above the anode. There's some text on it. It should face down. Push the cable back and put those nuts back. The nuts are of 10 millimeters. 10. So rotate this shiny metal to the right, otherwise the screws can come out. And this is the temperature sensor, which is inside that tube. It looks like that. That's the black wire which enters into that pink thing. And it is simply inserted there. Now reconnect the electric wires, the blue and the red. Blue, red. I put the plastic covers back with these two things on the lower side, below that connector, and try to close it. Now don't put the cover back because we have to check for water leaks also, and don't plug it in yet. Insert this small piece of rubber there to the thermostat so that it will hold it a little bit. Here's a sink and its furniture, and this water heater will not exactly fit inside there, the door is not closing, and the depth of this furniture is, let's call it 29 centimeters. So 29 is not enough for that water heater, 33 at least. Now in this case, this is my warm water, it has red stripes on it. I will leave that untouched and I will use the cold water. So the cold water has to enter here. This has a rubber inside and it can be threaded on. Manual tightening should be enough in this case. And the other one is extended. And that has to go onto that one. Water enters here from there and water exits here into the tap. And meanwhile, let's check for leaks. So I will start the water, opened and closed. This should fill up with water. Currently it's full of air also. Cold water enabled. There is no leak. This is getting pressurized. The water is pressurizing the air inside this also. The air is not yet exiting. It's only 10 liters, so it should fill up in a shorter period of time. It's not leaking yet. Not leaking yet. It's getting more silent. Is it leaking here? Not yet. This is manually tightened only. Power is not yet connected. Now let's see, only this one is enabled, the other one is shut off. Theoretically there's a cold and I connected it to the cold side. And yes, the air is escaping from the reservoir, from the 10 liter. So I neglected the red one, the hot water, because there's another hot water source in this bathroom. So I'm not using this one. I totally ignored it for this demonstration and I'm using only the cold. So I should have warm and warm after it is plugged in. So release the air. Water is entering meanwhile, it's pressurizing it once again and it's stopped. And it's full, so 10 liters is filled up quite quickly. The amount of water is not too large, the flow is reduced. The other one should not have any water, this is shut off. that is on the right side. So this is not yet fixed using the two screws so that I can check for leaks. Now here's a multimeter. Let's set it to the diode and the beep. That's a short circuit. Now it's closer to 0. And hope we don't have short circuit here also. No, we don't have anything. Probably the electronics are influencing things. Let's use a voltmeter also. Plug it in. Okay, let's plug it in. And nothing happens. No power consumption. Okay, so the final thing is this one, I guess. Put it back. 0 watts. Don't electrocute yourself. Now let's rotate this. And it is on and it's consuming 2200 almost watts. So when it's off, it's totally off. 0.0 watts. Power it on just a little bit. And let's see how much time will pass until we have a little bit of warm water. Let's just shut it off. It's off. Let's see what will happen. Is the water slightly warm? Nothing. It's cold. It's kind of cold. More. I'm curious how fast it's heating up the water. So when I power it off, that time stops there. 1 minute and 16 seconds. And when I power it on, it continues. So I guess it was powered on and it consumed 1 minute and 20 something seconds. Let's check the water temperature. And it's not cold. It's not cold at all. So it already warmed up the water a little bit. If we wait too much, even that light will turn off because it is set to a low temperature. And it was warming the water for 2 minutes roughly. It is consuming a little bit more than 2000 watts, 2150 something. And it's definitely warmer. Yes, it's warmer. In 2, maximum 3 minutes. The temperature is roughly identical, so it's heating up quite fast. It's still the same temperature, and if the thermostat is really working, that lamp should turn off by itself because it reached the desired temperature set by this gray one. And there was a pretty large click and the lamp is off after 5 minutes and a little bit. And let's check the temperature, which is not set too high. But yes, it's warmer than before. Let's set it to an even higher temperature. It clicked once again. And after 7, almost 8 minutes, my cable is a little bit warm at 2000 watts. And this is slightly warm. Mine is warmer. So this cable might be thinner than this one. This doesn't heat up that much as this. So don't use thin cables for 2000 watt power consumption. So hot water is being prepared under the sink. It turned off at 11 minutes and 45 seconds. Let's check the temperature. Here's the thermometer. Yes, it's definitely warm. I mean, too hot. Ouch, it's too hot. Let's see this. Yes, that's the metal exterior. Let's see that. 50 degrees Celsius, 51. And it is almost on the letter E after around 11 minutes. Ouch. So 50 degrees is too hot. 52. Okay, so it's fully functional and it powered itself off. I can tighten the screws back. It was not leaking before. 10-liter water heater, so it stores hot water. If you don't have electricity at this moment, you still have 10 liters of hot water prepared. So that's the Thermomate water heater, under sink 10-liter water heater. Let's set it this time to amps and enable it. And yes, it's consuming 9.1 amps at 224-26 volts AC off. And now the voltage of course is the same. The amps are 0. The water is burning. Steam is somehow not visible, but it's burning, it's too hot. 52 degrees, 26 on the wall. 52 there where the hot water is. Now don't remove those 5 large nuts because all the water will come out. There's a hole on the front of the entire water container. This is the water inlet, the blue one, and it's hot. The output, of course, it's hot because warm water exited there. And this is also hot. Less hot, but it's hot. So heat is being lost here also a little bit. The outside of the plastic is colder, the inside is somewhat warmer. Let's put the power cable back. Power is disconnected. Connect the left side, this one, and attach those 2 screws. This is inserted, push in the rubber. So this furniture is not closing, it's not large enough. Let's analyze this safety valve also. This is for pressure relief and it should be mounted on the cold side, just as shown here. It's blue. So this is the blue, that is blue, and I should remove this. Not exactly now. Water is shut off, let's try it. We have a little bit of pressure. Let's release that pressure. Okay. Even more pressure. So water is being released from this hose. And it almost stopped. More water. That's coming only from the hose and from the tap. So this should be mounted here. It has a rubber inside, so no Teflon tape is needed on the thread. So air or water can pass in that direction from the top to the bottom. So when I blow air inside here, it should exit there. So air is going that way. Now if I try to blow air from this side to the opposite direction, contrary to that arrow, it should exit here. If I provide enough pressure, which I can't with my lungs, then it should exit, but if the pressure is too low, then lift this up and then it will exit. So when the pressure is large inside the boiler, the pressure is being released here on the small one. And why is this on the cold side? So when the pressure inside the boiler is too high, then the contents are eliminated through the cold one. The cold one in this case goes down to the bottom of the boiler, and thus the colder part of that water is being eliminated here on the small. If you mount this to the other side, to the hot water, then hot water will come out. So a safer, low temperature water is being eliminated. Now put that also back. This also has a rubber inside. 1/2-inch connector. Manual tightening is usually enough. And the tube has to go to a sink somewhere. Shut off this first. Release the water. It was pressurized. Inside is still hot. Ouch, it's almost burning. Although it's disconnected. No water should leak here. This tube is not filled with anything, so this valve opens only at high pressures. So if you set this to the maximum, then probably that valve will push out some of the air and water. Water might boil in some cases. Since the boiler is full of water, it's much harder to lift it up. 10 kilograms plus the weight of the machine.